Cubic functions grade 12. So in this cubic functions grade 12 tutorial, we are going to work on how to determine the equation of a cubic function, or how to determine the equation of a cubic graph. Now, when you work with cubic graphs in grade 12, you need to be able to answer questions like these, where you have two variables missing. Sometimes you'll have three, and then here we're given the first derivative and the second derivative there. So in this functions and graphs grade 12 tutorial, we are working on this question. Hi guys, Lever here from Bright Young Brains. So a question like this, funny thing is, well, it's not haha funny or anything. In an exam, it's 7 marks, and honestly speaking, that's a lot of marks for a question like this, because a question like this is actually pretty simple, like super duper simple. The reason why we're saying this question is super simple is because we need to work out two variables and we are given two pieces of information, which is more than enough, because whenever you need to work out two variables, all you need is two equations, and these two pieces of information can be used in two different equations. Now the idea is they want us to get the equation of the cubic function there, and getting the equation of the cubic function just means we should get b and c there. So to get b and c, what you want to recognize is that here, this is important. This says in the first derivative, if you throw 1 where x is, your gradient is a 12. This is saying in the second derivative, if you throw 1 where x is, you're going to get an output of negative 24. So simply put, this we're going to throw it into the first derivative, this we're going to throw it into the second derivative, and then we're going to solve b and c simultaneously. So to do that, let's get the first derivative and let's get the second derivative. Getting the first derivative, we just have to differentiate this. And differentiating this is quite simple because we can use the power rule for each term there. Differentiating this, we know that 3 times 3, that's just 9. And then here, 3 minus 1, that's just a 2. We have differentiated using the power rule. And if you want to learn how to differentiate, the calculus playlist has a tutorial on how to differentiate starting from the basics. So here all you do is exponent times coefficient, and then removing 1 from the exponent there. That's what we do. That's what we did. Here we just repeat that process. 2 times b is just 2b. Remember, b is just a coefficient. It's just a value. So 2 times b is 2b, and then 2 minus 1 is just a 1. So there's a 1 there. Here, you want to recognize that the c is just a coefficient. X has an exponent of 1. So here, 1 times c is just a c. And then 1 minus 1 on the exponent position, we know that you're going to have the x to the power of 0, of which anything to the power of 0 is just a 1, so we don't have to write it there. This is a constant, and we know that anytime you differentiate a constant, it just falls away. The reason it falls away is because this is technically having x to the power of 0 there. Now when you say 0 times the negative 27 there, it's just a 0. So you see, it's just a 0 there, so you don't have to write it down. That's why we say anytime you differentiate a constant, it just falls away. So this is your first derivative. We said we need the first derivative and we need the second derivative. So here we have gotten the first derivative. Let's just get the second derivative as well. The second derivative is literally a matter of you differentiating this again. This is your main expression. If you differentiate it, you get this. It's the first derivative. This is not a 1, it's just, an apostrophe there. Yeah, I think that's called an apostrophe. So your second derivative, you just have to take this and differentiate it again. That's why your second derivative, you're just going to say 2 times 9, that's going to give you 18. And then 1, remove it from 2 there, you'll just have 1 as the exponent. Differentiating this, you want to recognize that 2b is the coefficient there. So here, 1 times 2b is just 2b. And then 1 minus 1 there, we know that you would just have a 0 there. So here, x to the power of 0, that's just a 1, so we don't have to write it. This, remember, it's alone. You see, it's a constant here. And differentiating a constant, it just falls away. You see, we don't have to know what c is. All we have to know is that there's no x here. You see, so this is a constant, meaning when this has been differentiated, it will just fall away. So this is our second derivative. Now the good news is we have information that we can throw into the first derivative and we have information that we can throw into the second derivative. So let's use this information first. Using this information, all it means is in this equation where x is, we have to throw a 1, and then where this symbol is, we have to throw a 12. Because basically all this is saying is if you throw x in this equation, the output is a 12, of which we know the first derivative gives us gradient, but then for now that's not very important. You see, all we need to know is that throwing x as 1 is going to give us an output of 12. Now with this equation, there's not much that we can do. We can simplify, and then this is practically as far as we can go. You can label this equation number 1. Now the good news is you can pause here because you really can't do much here. You can just leave it. Your second derivative though can help you carry on and eventually get both b and c, because if you look at your second derivative, this is saying if you throw x as a positive 1, the output there is a negative 24, of which we know that if you simplify this, you have negative 42 on the left, which is giving you a b value of negative 21. So we have b, and luckily we know that we can throw equation 2 into equation 1 and then get c. There we go. You have b and you have c. They asked for the equation of the curve. So getting the equation of the curve, you throw b there, you throw c there, and then this is your final answer. Now for cubic functions and more tutorials on differential calculus and exam-style questions, you can check out the course platform. The link to that is in the description. And on the course platform, there's also a free course there where I lay out how I went from 40s in grade 11 to like 80s in grade 12. So if you're keen on finding out how that happened, you can just head over to the course platform. It's 100% free. That specific course though, the one where I basically talk about how I went from 40s to 80s. I lay out everything, you know, I even show you my reports. So if you want to check that out, the link to that is in the description.